So in our final installment, I guess, of looking at the elementary school math curriculum expectations for coding, we are now looking at the grade 6 expectations. And when you first glance at it, it says solve problems and create computational representations of mathematical situations by writing and executing efficient code, including code that involves conditional statements and other control structures. And you may remember from our last video for grade 5, this is actually the exact same expectation. But the difference is when we go to the teacher supports, we'll notice there's a couple extra key concepts that are not contained within the grade 5s. And the first one is that a flow chart can be used to plan and organize thinking. And when we go a little further down, it also then starts talking about using loops whenever possible, and conditional statements like loops can be nested to allow for a range of possible outcomes or to implement decision trees. And so what we realize at this point is grade 6 is really the accumulation of all the expectations that we've dealt with at the elementary level put into this one aspect. And so we want to make sure that we have within our grade 6 project, we've got that sequential aspect, we've got that concurrent aspect, we have that nested aspect, we have that repeated aspect, we have our conditional statements, and not just one conditional statement where it's the if-then, but in fact, we're actually looking at using loops and flowcharts now. And this is where it gets really exciting, because up until this point, we've really just been doing these instructional videos, and I suspect you've been asking yourself, but how do I create an activity out of this? What does this look like? What can I do with my kids who are going to meet this expectation? Well, I've got the solution for you, folks. And the solution was actually brought to us through COVID. And every single school and every single student has seen something similar to this, and that is our school flowcharts as to how we navigate through our hallways. And so when we look at this, we realize, and this is our St. Emily floor plan, and in fact, I can even take this as that pixelated image, as we've been talking about before for our grade 1s, where I have a blank one where we can simply print it out and have the kids just draw right on it as to where the flow chart is, and here's our answer key. And if we look at it, we start off and we have our sequential aspect, where we have one arrow and it's pointed in one direction. And so we have a start point and we have an end point. And so that would be simply our grade 1 expectation, where I would just draw one arrow on here. To get into my concurrent aspect, I simply would have two arrows, because the two arrows represent two different individuals. We would have one person walking in this direction, we could have another person walking up here, and they're both going in the same direction, going in the same fashion. So that would be considered concurrent coding. If we think about our grade 3, where we talk about repeated, well, obviously at this point, we have all of our arrows through here, we have all of our arrows through here, we have all of our arrows through here, and so now we have our repeating aspect. And then our nested aspect for grade 4 is, this is actually a forever loop. And so we would draw all of our arrows through here, and we would come all the way back to our start point, where we would repeat it all over again, but it would technically even be in a forever state, because we would be able to go around and around and around for as long as we wanted. The great thing that, and why I'm using this example though, is there are situations though within our day where we don't want to go forever, where we actually want to be able to get out of that nested loop. And so that's where our conditional statements come into play. And so in our conditional statements, if we look at grade 5, I have an if-then. If I want to go this way, then I'm going to turn right. However, if I want to go this way, back to my grade 6 room, then I'm going to turn left. And then finally, from our grade 6 standpoint, this is our entire flow chart where I have all aspects and all possible scenarios in play, where I'm going to have my one ways going that way. I'm going to have my grade 6s who come down here. They go into my loop, use the restroom or the water fountain, and once they're done, they're going to turn back there. But my grade 5s, they would come down through here, do the same thing, but then turn there. And so I've got my complete flow chart, including as to how I get in and out of my exit doors. And so that really gives you the 6 different scenarios of how we can meet the coding expectations. Clearly, we can draw all of this right on our blank paper if you don't have access to technology, nor not particularly sure how you would code that in Scratch or Lynx. And so it can be that simple, or like I said, as we're going to see from our student ambassadors, they're going to show you shortly how they would code this both in Scratch and in Lynx coding, where you're going to see their sprite or their. So hopefully you'll find that helpful and feel free to use this activity. I will include a link to where that document is contained within our YouTube video as well. If you ever want to access it in the future, please feel free to do so. At this point, I'm going to turn it over to our student ambassadors.
All right, so today we are going to create a flow chart to help us know how to move around our school using Lynx coding. So I'm going to run our code for you. Just takes So what's going to happen is we're going to go all around our hallways to get to the junior water fountain. Okay. Well, while it goes, I'm going to explain to you how this works. So to make our turtle term, we're going to use the set heading command and set it to 90, then glide 450, and you can choose whatever speed you want. And now we're going to use the set heading command, but this time turn it to 180 to make it go down, and glide 320, set heading 270, glide 310, set heading 0, glide 315, set heading 270, and glide 100. Now you might notice that we have another piece of code here. This is our loop. So instead of just having it go around once, it's going to keep going around again and again. So I'll show you how to do that too. Set heading 90, glide 335, set heading 180, glide 320. It's basically just this code but in the forever command, except we don't have the last set heading and glide. And that's it.
Hello everyone, this is Michael here. I'm doing another Scratch project from Mr. Moore. So, in this Scratch project, we had to make a sprite move down the hallways of the school using this picture. As you can see, the beetle is moving through the hallways. And yeah, so here's how I did it. So first, I don't know if you noticed this, but I actually have put multiple balls right here and made them really small. so that the beetle can slowly glide to that position. The reason I did not move steps is because steps go too fast, so you can't see them. So which is why I created these balls so that the beetle could move to certain points. And if you noticed, I actually put this in the middle so that as soon as the beetle hit here, he would go here. So anyways, thank you for listening and bye.